In this video, we will explore two properties of negative exponents that are very useful when simplifying expressions containing negative exponents. First, let's look at the fraction shown on the slide, x to the negative fourth over y to the negative fifth. We want to express this fraction using positive exponents. First, notice that this expression is equivalent to x to the negative fourth times 1 over y to the negative fifth. Our first factor, x to the negative fourth, is simply the reciprocal of x to the fourth. Our second factor, 1 over y to the negative fifth, can be simplified as follows. 1 is equivalent to y to the 0 power. And now using the quotient rule for exponents, we can subtract the exponents. So we have y to the 0 minus negative 5, or y to the 0 plus 5. So that factor simplifies to y to the fifth. Returning to our original problem, we can see that we have 1 over x to the fourth times y to the fifth, or y to the fifth over x to the fourth. If we compare this answer to the original problem, we can see that the original numerator, x to the negative fourth, has been moved to the denominator with the sign of the exponent changing to positive 4. The original denominator, y to the negative fifth, has moved to the numerator with, again, the sign of the exponent changing from negative 5 to positive 5. So we can conclude, accordingly, a factor can be moved to the other side of the fraction bar if the sign of the exponent is changed. Said algebraically, this property is a to the negative nth power over b to the negative mth power equals b to the mth power over a to the nth power. Now let's look at another property of negative exponents. We want to take the quantity x over y to the negative third power and express it using positive exponents. First, note that we're raising a quotient to a power, so we can raise both the numerator and denominator to that power. So we have x to the negative 3 over y to the negative 3. And now, by the property we just learned, we can move the x to the negative 3 to the denominator as x to the positive 3, and move y to the negative 3 to the numerator as y to the third. We can go one step further if we'd like to write this fraction using one common power of 3. We can write the quantity y over x to the third power. If we compare this answer to the original problem, we can see that we've found the reciprocal of the original fraction, and we've changed the sign from negative to positive on the original exponent. So our conclusion, any base to a power is equal to the reciprocal of the base raised to the opposite power. Algebraically, we would say the quantity a over b to the negative n power equals the quantity b over a to the n power. Now let's simplify some expressions using these properties of negative exponents. In problem 1, we have the fraction ab to the negative sixth over c to the negative eighth. Note that we have three factors here. The first factor is a to the positive first power, so that should stay in the numerator. However, the second two factors have negative exponents, so we'll move them to the other side of the fraction bar. B to the negative 6 moves to the denominator and becomes b to the sixth. C to the negative eighth moves to the numerator and becomes c to the eighth. So our answer is a c to the eighth over b to the sixth. Moving to problem 2, we have negative 12x to the negative 7th over 3y to the 9th. First, note that we can simplify by dividing the coefficients to obtain negative 4. Next, we have x to the negative 7th in the numerator, so this factor should move to the denominator and become x to the positive 7th. Y to the 9th already has a positive exponent, so it should remain in the denominator, and our answer is negative 4 over x to the 7th, y to the 9th. In problem 3, we have a fraction raised to the power of negative 5. So to begin simplifying, we will write the reciprocal of the fraction to the positive fifth power. Now we can apply a power of a quotient by raising both the numerator and denominator to that power of 5. In this case, we would have y to the 5th power, and then in the denominator, x to the 4th to the 5th, we use the power rule to multiply those exponents and obtain x to the 20th power. Finally, in problem 4, once again, we have a fraction raised to a negative power. So let's begin by writing the reciprocal of that fraction to the positive power. So we have b to the negative 4th c over 6a cubed, that entire fraction squared. Next, note that within the fraction inside the parentheses, we have b to the negative 4th power. So we can move that factor to the denominator, leaving us with c over 6a cubed, b to the 4th. That entire fraction should be squared. Finally, we can apply the rule for raising a quotient to a power to obtain a numerator of c squared and a denominator of 6 squared, or 36. Then applying the power rule, a cubed squared would be a to the 6th, and b to the 4th squared would be b to the 8th.